Okay, here we are in a Colab notebook. I've pip installed Leap. You can also do this locally, run this in a script, whatever you like. Probably include this in your model's evaluation function. Using a ResNet 18, I've got my Leap API key passed into the config there, and I've generated one prototype for the class 1 in ImageNet, which happens to be Goldfish. Once that's done, you can head on over to the Leap Labs dashboard and see your prototype. There's Goldfish, and you can also see the features in that prototype that are entangled with other classes. And of course, you've got the entanglement chart, so you can look at the actual entanglement values over here. We also integrate out of the box with weights and biases, so I'm using the same model, but all I've done is pass my weights and biases API key and my weights and biases entity there. I picked 3 random classes for this one. And if we head over to the weights and biases dashboard, we can have a look at the prototypes that we've generated. Here we go for tiger, castle, lemon, and the entanglement chart over here, if that works best. I've also done the same thing for a different model, for ResNet 101, much bigger model, and now I can directly compare the prototypes generated from each of these classes, as well as the entanglements for 2 different models. We can also use the interpretability engine to do local feature isolation. So given some input image, we can ask which regions of the input image determine the prediction. Here we've got an input of a bowl of fruit, and we have isolated the features for the top 3 classes that were predicted: pineapple, orange, and banana. And here we can see that's what it's looking for when it's making a pineapple classification. Same for orange and banana here. This is actually wrong. There's no banana in this fruit bowl, but it's using this kind of like curve of the lemon that looks kind of like a banana. It's also using the context of the fruit.